Welcome everybody to another edition of Beard Science. I'm the Beard, and today we're going to talk about one of my favorite things, and that is something called action and reaction. In 1728, a giant of science, Sir Isaac Newton wrote his most famous book, A Philosophiae Naturalis Principia Mathematica, which was his landmark book on how things move and where he wrote the three laws of motion and, of course, quantified some of the laws of gravity. Now, of the three laws, they're all elegant and beautiful, but my favorite, of course, is law number 3, which is action and reaction. Action and reaction affects us every single day, and we actually use this law to help us move things. How do we do that? Well, let's take a look. I'm going to take my rollerblades here and put them on my feet and push on something else. Let's see what happens. Okay, if I push on this post, which is not moving, in this direction, which way do you think I'll move? Let's find out. Here we go. That's gravity, but that's for another lesson. Let's keep going. Oh boy. So, the next time you do a push-up, think about the fact that you actually come down, you push down and you go up. You push down and you go up. You push down and you go up. These should be more likely called push downs. Think about that. One of the ways in which we use action and reaction is in rockets. I love rockets and so many innovations now with SpaceX actually being able to go into space. So a rocket is essentially fuel, which escapes in one direction, and if we have a push in one direction, Newton told us we'll have a push with the equal amount of energy in the other direction. So if I let the air, which is being compressed right now by this balloon, if it actually is pushing down, which way does our rocket go? Well, of course, the rocket goes up. So for those of you who are really into math, here is actually the formula, which simply says this. It says that according to the formula, force number 1 is equal to force number 2 in magnitude in the opposite direction than the force that is exerted by 2 on 1. So basically, we have the same magnitude on both sides, but this is in the opposite direction, so we have that action and reaction working.